Okay, 8th grade, we're going to be talking about ratios and proportions today. So the first thing we're going to do is kind of define those things. A ratio is a comparison of two numbers by division. So there's a couple different ways we write this. Word form is x to y, x colon y is one way, or the fraction form x over y. We'll be using fraction form a lot because fractions we know how to work with very easily. The second word we need to define is proportion. And a proportion is an equation, because we've been talking about equations a lot. And this equation is stating that two ratios are equal. For instance, maybe we want to know if 16 over 24 is in proportion to 2/3. Well, if we reduce 16 over 24, dividing top and bottom by 8, we would get 2/3. So that means we can say that 16 over 24 is equal to or in proportion to 2/3. Sometimes though they won't tell us just numbers. They'll give us some variables because we're solving equations. That's what we like to do. And they'll tell us that x over 3 is in proportion to 4 over 12. Solve for x. Well, what we really want to know is, what did we do to get from 3 to 12? What did we multiply by? Well, 3 times 4 gives us 12. So that means to get from x to 4, we also multiplied by 4. So I want to know x times 4 equals 4. What is x? So if we solve 4x equals 4 and divide both sides by 4, we will get that x is equal to 1. Okay? So I not only have this ratio, but I also have, or the proportion, I also can set up equations to solve. Okay? So when I talk about ratios, so let's say I have 2 to 1 is equal to 10 to 5. Those are in proportion to each other. And if we wrote this as a fraction, it would look like 2 over 1 is equal to 10 over 5. But we have some special language we use, especially when it's in the colon form. The outside numbers are called the extremes. So in our fraction, that's the numerator over here and the denominator over here. The inside numbers are called the means. So in our fraction, those are these numbers. Okay? So the means really mean the middle numbers, or middle terms. And you know, when we talk about like mean, median, mode. Mean means the average, which is kind of in the middle. We're talking about those measures essential tendency. So it makes sense that when we're talking about proportions, those middle terms are called the means. The extremes are the first and last terms. Kind of like when we talk about measures essential tendency, they're kind of like the outliers. Except for they are in our data set and they do make sense, and they're in our proportions and we have to use them and like them. Okay. So we also need to talk about not just ratios, but when do we use ratios and proportions? Well, we use them with rates. And you've heard about rates before. A rate is a ratio of two measurements that have different units of measure. Okay, so for instance, when you drive to school in the morning, and you don't drive yet, but your parents do, they drive a certain number of miles, and that mileage is measured in miles per hour. So that means the miles are in ratio to the hours spent driving. Even if they only drive for 15 minutes, 15 minutes is still a quarter of an hour. It can be expressed like that. Likewise, when you're at the grocery store, sometimes they have good rates on things, like maybe bananas are 49 cents per pound. You've seen this. The cents per pound is a rate. Okay, we're taking two different units of measure, money and weight, and we're using a ratio to compare these two numbers. Okay. Likewise, we have a unit rate. And a unit rate is a special kind of rate. In that it is a rate being compared to one of another item. So maybe it's 49 cents per 1 pound. That's a unit rate because I'm comparing how much it costs per 1 pound. That being said, I can get 9 pounds of bananas if I really want bananas badly. And it's not 49 cents for it all, it's 49 cents per pound. So I would need to multiply those 49 cents per the 9 pounds that I have. So let's look at another example of this. Let's say that you want to open up a store, maybe a Waffle House. And Waffle House, because it's my favorite breakfast joint, opens 232 stores across the country inside of 2 years. I have no idea if that's realistic or not. And I want to know how many stores they'll open in 3 years. Well, in the first example we did, I moved from 3 to 12 and I said, oh, I multiply by 4. Well, there's not something really nice that I multiply by to get from 2 to 3. So what we're going to do first is find the unit rate of this. Okay, so I want to know how many stores they open in 1 year. And I can get that by dividing. 232 by 2. And that gives me 116 stores per year. Okay. Then I need to know that I open 116 stores in a year, and I'm multiplying by 3 years. When I multiply those together, I'm going to get 348 stores, which is my X. The units on this do something really cool, and I know Mr. Suddendorf always wants you to show units. So originally I'm looking at stores per year. So that's like stores over years. And then I'm multiplying by years, and we can put that over 1 if I want. What's going to happen is those years cancel. Come on, cancel. And I'm left with stores over 1, or just stores, which happens to be my unit when I gave the answer 348 stores. Okay? There is another way to solve proportions. So let's say we have x over 10 equals 3/5. Instead of saying, what did I do to 10 to get to 5, I can cross multiply. So some of you call this the butterfly method. I'm going to multiply x and 5, and then I'm going to multiply 3 and 10 and set them equal to each other. So 5 times x is 5x, 3 times 10 is 30. I have a simple one-step equation I can solve. Divide both sides by 5. I get x equals 6. The last thing we need to talk about is going to be really important for an upcoming project, and that is scale. Scale is a rate used to make something bigger. And this something might be something like a picture or map or whatever. And it doesn't necessarily have to be bigger. It could also make something smaller. So obviously the United States doesn't fit on a map, or we would use a lot of paper to get it, to try to get it to. Instead, we draw it to scale, and we make a scale drawing. Those maps are scale drawings, and they are smaller. And that's what it means by scale model or scale drawing. Okay, and when something is too small, we can also blow it up. So scales work both ways. We can make actual things that are too big smaller, or we can make things that are too small bigger. And you'll see this a lot in lots of different subjects, social studies being one with this maps. Science, sometimes molecules are too small to actually look at, so we make big scale models of them. Okay? So this is cross-curricular beyond just math.